In these 20 minutes of sitting, we will be talking about Microsoft approach toward artificial intelligence. My name is Parinaz, and I was working in the data science field for more than 8 years in big consulting companies. And today I am an ambassador and cloud solution architect in Microsoft in the field of data and AI. So Azure Azure AI is a set of AI services that are built upon Azure and deeply integrated with Azure data app development and compute service and tools. At the bottom here, we have Azure Machine Learning, where data scientists and developers can build, train, and deploy models. This is the only cloud ML service that enables developers for all skill level to build ML models, from code first experience to drag and drop to automated machine learning. And Azure Machine Learning at the bottom still provide advanced MLOps capability with built-in integration with Azure DevOps, and this will enable developers to achieve model reproducibility, model validation, and model deployment, and model retraining capacities. And finally, this has been built on an open source foundation, and developer can choose Python tool and process their choice and even get started in their laptops. And further up over here in customizable AI model, we have customizable vision, speech, language, and decision models, which are cognitive services based on or breakthrough research. Not only does Azure AI have the greatest number of pre-trained models, we are only one that can enable development anywhere on premises, on edge, and even other cloud through use of container. And on top, we have scenario-specific services. You see, that is built for professional developers. Like, for example, bot services built on bot framework, which is the most popular open source-based bot framework. And this includes with the Azure Search, or cognitive search in another word, which is the only cloud app search service with built-in AI capabilities. And we have, for example, form recognizer, I will show you, that has designed to work on a specific type of documents, which are forms. And it extracts key value pairs from forms and thereby automating the data entry task. So, and finally, we have a video indexer, which will extract in-depth metadata from video and audio content. So in cognitive services, we have 4 categories, that can provide the most comprehensive set of pre-built AI technology that are easily accessible via RESTful APIs. We have perception-based service that understand the word using the speech, language, and vision. And decision service can deliver a specific recommendation to enable informed and efficient decision making. And then another service is web search, a service which surfacing the information from the World Wide Web of being. And with addition of several services over the last few months, we now offer the most comprehensive set of domain-specific AI services. Let me show you some examples to see how they work. Okay. So the first thing is computer vision in cognitive services. That, for example, you can feed it with some image, and it will give you a caption of that image. It will give you some tags of the object detected in that picture, and pre-built. You can see the faces, the different object in that image. And for example, if we look at this, which has some text, you can see the caption, the domain, dominant colors, and also the object detected in the specific picture that you will feed to your system, like this. And then, for example, using the optical character recognition, it will read even the text. And imagine that there are several faces in the image, you can detect them. So computer vision is a cognitive service that train on many different classes, like more than 1,000 of the classes, like bus, van, for example, car. But what if you want to classify the different type of the car, for example? You want to classify on Ford, for example, or BMW or something, and you don't have data scientists in your organization to create those ML models from the scratch. And here you can use the custom vision inside the cognitive services. Okay. So here the studio to how you can create a custom vision. So imagine that you want to detect the crack in a windshield of the car for example, something like insurance companies. And the only thing that you need to do is that you will create a project in this studio, and you will decide if it's a classification or a detection of something, and then you will create that project. And the only thing that you need to do is to gather some images of, for example, unbroken windshield over here, and put it in one class. And the other is the information about some image and collection of images about broken windshield over here. We upload it. And then we will go ahead and take a look at the quality of the images that we uploaded. These are the images of healthy cars, no broken windshield. And you see the reflection of the tree on the windows can be problematic. So I will feed it some image of the trees or some sceneries that can be reflected on the windshield, not to confuse the system if they are cracked. So I will go ahead and create some bounding box around the broken part in windshield in broken cars over here. And even I can create several, like this tree cracked in this windshield. Give it a tag. And then I will investigate if it's correctly labeled. And then I'm happy with the data set that I have at the first step. I will click on train, and that's it. I have the possibility to use the quick train or a more advanced, which will be more iteration in a neural network in forward and back propagation. At the first iteration, I got a good precision, but I want to test it to see how it works. So I will feed it with some images that the system has not seen to test it. This is correctly detected. Another image like this. This is correctly detected. This is good enough. But this part, I see that it detected some something that is not correct, but a reflection of the tree. So I felt a need to go through more advanced training. I will assign more time to that, more iteration. The precision went higher, and the recall is higher, so it should do it better. So I will try the system again with first iteration, which was that basic one iteration is 56% of the confidence in detecting that crack. But with the second system is 70%, which looks better. So at the end, I can go ahead and publish it and use that REST API and endpoint to put it into the production. So the other thing, imagine if you, I want you to think of putting these cognitive services into the production. And imagine that if you want to do that, for example, computer vision in each frame of a video. So this is where another service, which is Video Indexer, will come along. It will help you to unlock insight from a spoken audio that is transcribed and translated, and sentiment, face, and etc. So if you want to try this system, you will, this is a ready-made system that you will feed it a video, and it will start to correct that video. It's over here. And when we click on that, we can see that we can see that all the people in that clip or video has been detected, the scenes, the topics, the labels for different sceneries, even the sentiment has been detected. The timeline for something which happened. And even where in that video the picture of this boy is has been shown, so on and so forth. So I can go ahead and look at some. I want to search for something like golf, for example, right? Golf. And then I see that in first 21st second of this video, there is a scene of golf. I will go ahead, click on that. And when I look at it, it's here. So you can imagine that how it can be useful when you have a big repository of the videos like this, and you want to actually find something instead of sit and look at it. I will look at the celebrity Scott over here, and in my repository of videos, I can see that where Scott has been appeared. Right? So this is another thing. And so this is a very brief introduction over the pre-built model and ready-made solution that you can that can accelerate your intelligent production. Now, Azure Machine Learning is a platform if you want to build everything from the scratch for operating the machine learning workload in the cloud. This platform can be used for any kind of machine learning, from classical machine learning to deep learning, supervised, unsupervised learning, whether you prefer to write Python or R code or zero code, low code operation like in what we have in Designer, I will show you. You can build, train, and track highly accurate machine learning and deep learning model in Azure Machine Learning Workspace. You can also start training your model in your local machine and then scale it out into the cloud. This service also interoperates with popular open source tools like PyTorch, TensorFlow, and Scikit-learn, and built on Microsoft Azure Cloud Platform. You can manage the scalable and on-demand compute, and also data storage and orchestration and model registration and management to keep a track of the models that you created and or keep a track of the metrics and monitoring your training experiments. This is how it looks like. So automated machine learning while hyperparameter tuning enable you to try multiple hyperparameter combination with using a specific algorithm. Automated machine learning enable you to try a multiple algorithm and pre-processing transformation with your data. This combined with a scalable cloud-based compute makes it possible to find the best performing model. So the only thing that you need to do is that you will go ahead and feed it with your data, take a look at your data, you will select which one is your feature and start the run. That's it. We have another thing which is a machine learning designer, which is a graphical environment for creating machine learning models. Okay, and publishing them as service that can be consumed by client application. The main benefit of this is that it allows for no-code development of machine learning solution through a drag and drop interfaces. So if you look at this, you will just use the drag and drop and then run it like this. But if you're very happy with the coding and you use machine learning notebooks, you can go ahead and use this part, which is a place for running advanced ML algorithm for those who are good in code, and you can do end-to-end solution with the help of Azure Machine Learning Python SDK. So this is the environment. You will go ahead, create a Jupyter notebook on a compute that you assigned to this environment, and then you will run it. So as I don't have enough time to show the example of how each of them works, you can see the environment of Azure Machine Learning over here. So if I want to, I will launch it like in here. This is the environment. We have automated ML over here, notebook designer are there. The only thing that I want to do is I want to classify diabetic or non-diabetic people. So I will choose the target column or label column. And my problem is classification. I want to decide on what kind of metric is more important for me. Execution, how the system will stop training. The validation can be automatic, or you can decide if you want to have a k-fold cross-validation, etc. Concurrency, if it's two or what, I will save it. I will take another look at the features, like if I'm happy with the data type or whatever. I will save it and finish. It will create the it will try a different algorithm with different parameters for me. And here we have a data guardrail that it will tell me what was the problem with my data. It was unbalanced, it was skewed, or like what. And then it will start to create the models. We can see the list of these models over here. We see that a cluster that we're creating is resizing. It means that more nodes are getting engaged. So here we feed a list of models here. I can go ahead and change the view of the metrics, for example. How the AUC, for example, is getting improved by different iteration. So I want to take a look at this model, for example, and I can directly deploy this from here, or I can do some visualization over ROC curve, for example, or lift curve or confusion matrix created by this. This is the run. And when I'm happy with the model that I have, I can cancel the rest, trying more models. Here I see that 98% of AOC is enough for me. I can go ahead and click on deploy the best model, or I can look at the detail of the model, the output. You can get a scoring file for that as well, and a Python file for training as well. So this is actually, I'm sorry, you can go ahead and deploy it in a Kubernetes instance, or in training, in a test environment, in a container instance. So this is the best way to find a base model for yourself. And if you want to use it, or you want to continue development by your own, it can give you a very good base model, in fact. So, so I want to give you an example of Vulcan Steel, which is an industrial steel provider that both manufacture goods like steel beam and prepare these goods for distribution. In this case, we're seeing that Vulcan operation of loading the steel onto truck to be sent to the market. Given that there is an average of 14 deaths per day from worker in industrial sector, workplace safety is a top priority for the organization handling large and heavy equipment and products. In addition, to not wanting anyone to get injured, workplace safety incidents are one of the costliest yet avoidable aspects of these industrial companies. Vulcan understand that it's in everyone's interest to protect worker in this condition. However, the scale, speed, and the complexity of this operation make manually ensuring this safety is not a very easy task. So Vulcan look into Azure IoT to automate the identification and warning of hazardous condition. So I want to show you how it works. Let me go to my account over here. So this is a dashboard that somebody who is responsible for the safety of the production hall can look here, we can see that the problem here is that it doesn't have the protective helmet over there, that the model that is already trained has not detected it. Okay, so we will go ahead and retrain this model to include that not wearing hard hat to my model as well. It will go ahead and train it on virtual machines. And then, so this is where the version 2 of this model has been applied. We deploy this model. On all trucks, because the trucks are equipped with a camera on the back of trucks. So this is where the system has been deployed on edge on back of the truck. So here you see that this time that hazardous situation has been detected. So it means that if we want to put it into the real world production, we need to take care of the development, which is continuous, which is possible to reproduce the better model in the future. So
en annen som på trinnet mitt nå. Det den der jobben som jeg intervjuet for Cognite da. Hun jobbet I den stillingen I Cognite, og så var hun nå her da.
Ja, men kan du være på intervju hos Cognite?
Jeg var på intervju, jeg var akkurat den stillingen som hun hadde.
Hun hadde det, ja.
Hun hadde den stillingen som jeg var på intervju.
Og nå hun byttet til meg, eller? Sier du det til henne? Hei, jeg sa det akkurat, men du fikk jobben. Men du fikk ikke til intervjuet?
Jeg var på intervju, og så bare sa jeg ikke noe mer etterpå. De sa, du kan spørre oss. Så sa jeg aldri noe mer da.
Nå skjønte jeg ikke, men de valgte ikke deg. De valgte henne.
Det var begge parter kunne spørre spørsmål, men det var ingen som sa noe.
De ville ikke ha deg. De ville ha henne.
Nei, hun kom I 2019 da. Det var ett år henne.
Da kanskje de har en.
Okay, so is there any question?
Ja, men hvis de virkelig vil ha deg, har de sendt deg sjokolade.
Okay, is there any question? Okay, can you was there any question, because I didn't understand, you've been talking. Okay, so I continue. So another important thing that I just want to have a point here is that whatever system that you're creating needs to we need to focus here using AI responsibility. So what we need to focus here is whatever intelligent application you're building should be fair, which means that AI system should be clean from undesirable stereotype and biases like toward different genders, should be transparent, means that the output of it should be understandable to affected a stakeholder. Imagine when your system prevents a loan to go to a specific person. It should be accountable, means that the responsibility of the system designer about the system, how the system is behaving. And it should be reliable, means that the safety should be, say, the first and the last word. And it should consider privacy and security so that the data won't be misused. And last but not least, to be inclusive, means that it should empower everyone in the planet to achieve more. So I don't think that I have enough time, but I just tell you that that's why in this Ignite in February 2021, we released a public preview of the fairness dashboard, and explanation dashboard into machine learning service. So at the end, the greatest danger that for most of us is not that we aim too high and we miss it, but that is too low and we reach it. And please go ahead and try this link, and I hope that it cleared many things.